Imagine you're in the hospital and the nurse hooks you up to an IV. What is in that IV? Is it just water? No way. If you were pumped full of pure water, your blood cells would burst. How horrible would that be? That IV is full of saline, a liquid with the same concentration of solutes as your blood cells. Why is this important? Because you want your blood cells to sit in an isotonic solution. An isotonic solution is when two solutions, separated by a semi-permeable membrane, have equal concentrations of solutes and water. Imagine you're at a party and there are an equal number of guests in the living room and in the kitchen. It doesn't make much of a difference where you stand because you are equally as comfortable in either room. You have just as much space, you can move just as easily, and you have equal access to food. You don't spend a lot of energy trying to get out of one room or into another. This party is like an isotonic solution. Everything is equal from room to room. Now, compare this with a party where the living room is packed full of guests, while there are only a few in the kitchen. I don't know about you, but I would be trying to get to the kitchen as fast as possible. The concentration in each room is different, so people are moving around trying to equal things out. Nature likes equality, and that is apparent when it comes to solutions. Let's talk about membranes for a moment. A semi-permeable membrane is one that lets some things across while keeping others out. Your blood cells, for example, have a semi-permeable membrane. This allows things like water to enter and exit freely, but keeps other things, like fats and proteins, out of the cell. This membrane keeps your blood cells nice and supple and able to do their job without being stuffed full of whatever happens to be floating around in your bloodstream. The semi-permeable membrane is what keeps two solutions apart, allowing only for water to pass through. When we talk about solutions, we can compare two solutions that are separated by a semi-permeable membrane. A solution is a mixture of two or more substances, often in liquid form. If you dissolve salt in water, you are making a solution. The salt in this example is known as the solute, the thing dissolved in the water. The more salt or solute you add to the water, the higher the concentration of solute you have in your solution. Water likes to have things equal on either side of a membrane. It doesn't want to have more solute on one side than on the other. So, if it is presented with a situation where on one side of the membrane there is more solute than on the other, water will rush across the membrane and try to dilute the solute until both sides are equal. Basically, water is constantly comparing two solutions to each other and determining if more water is needed on one side or the other. We've taken the time to name these comparisons. If a cell has more solute than surrounding solution, this state is called a hypotonic solution. What do you think will happen here? Water will rush into the cell, trying to dilute the solution and causing the cell to swell up. If a cell has less solute than the surrounding solution, this state is called a hypertonic solution. In this case, water will rush out of the cell, trying to dilute the surrounding solution, and the cell will shrink down to almost nothing. Finally, if a cell has the exact same amount of solute as the surrounding solution, this is called an isotonic solution. Water doesn't really need to dilute anything, so it just lazily moves in and out of the cell. In this instance, the cells don't change size at all. Water moves freely, but doesn't need to dilute solute inside or outside the cell, so the concentrations remain the same and the cells are free to go about their business. Our cells need an isotonic solution. Can you imagine what it would feel like if water was constantly rushing into or out of your cells? It would be a real pain. So, our body has a particular concentration of solutes, and that concentration is equal inside and outside of the cells. This is why your nurse hooks you up to a saline drip instead of pure water. She wants to make sure that your blood cells are in an isotonic solution. Let's review. An isotonic solution refers to the state when two solutions have equal concentration of solutes across a semi-permeable membrane. This state allows for the free movement of water without the dilution of solutes on either side, and keeps cells functioning properly.